Hello, this video is on section 10.5, which is titled Graphing Square Root Functions. This is the last one of the chapter. And the two targets are to, of course, graph square root functions. And then the second one is to translate graphs of square root functions. And we're going to be mainly focused on translating when it comes to your different types of transformations. If you remember, translate is the same thing as shift or slide. We're not going to really be dealing with stretching or reflecting too often, but translate's the big one. So a square root function is any function that contains a square root with the independent variable in the radicand. And in most cases, when I say independent variable, that's going to mean your x is underneath the radical. And the parent function of every single square root function is actually going to be y equals the square root of x. And if all of these points on the x-axis relate to your x, and of course the y-axis points are for your y, if you plug in 1 into x, the square root of 1 is 1. Then if you plug in 4, the square root of 4 is 2. Then the next perfect square that we can get is 9. The square root of 9 is 3. So this is what the graph of the parent function of a square root looks like. It's like an x squared, where it's pointed upwards parabola, but half of it is tilted on its side, and it's slowly increasing, but it will always increase up to infinity for the range, and it will always go to the right in infinity. And right now the domain of this graph starts at the point 0, which I use my bracket to say that the point 0 is included, and it goes on to infinity. And I use parentheses because the point infinity cannot be included because infinity is not an actual point. Then the range is the exact same thing for the parent function. You start at the point 0 and you're moving up to infinity. Now the domain and range is going to change depending on if you're translating the function or not. Maybe you're shifting it to the right, so your domain will start at, say, 3 or 4, or you're shifting it up, so it starts there. But that's the starting point of the parent function, is the point 0, 0. It doesn't go to the negative on the x direction or in the y direction. Now, speaking of domain, when you want to find the domain of your square root function, that means the values underneath the radicand are not allowed to be negative. If it is negative, then you're not allowed, the number doesn't exist. You can't find the square root of -3 because that number does not exist. It's not rational to take the square root of a negative number. So like I said earlier when I was talking about domain, the values for the radicand that are greater than or equal to 0 is equal to your domain. So let's say if you have the function y is equal to the square root of x minus 4, what you need to do to find your domain is to take the expression or the terms that are listed underneath your radicand x minus 4 and set them greater than or equal to 0, because it's not allowed to be negative, so it's not allowed to be less than 0. It can be greater than or it can be equal to. Then solving for x means that all of your x points have to be greater than or equal to 4. This is another example of how you can write a domain, that your x starts at the point 4 and it goes on that way. So that's what the graph looks like. Another way you can write it is starting at 4 and going to infinity. Now when it comes to translations, this is a review of what we talked about earlier, where you can add or subtract some numbers on the inside of the function, which is what this h is for, and you can add or subtract some numbers that are on the outside of the function, which is what the k represents. Now the numbers that are for the h, plus or minus, correlate to a horizontal translation, or a left or right translation. Like this example up here is a horizontal translation to the right of 4. Now remember, horizontal is always the opposite sign that you see, so since we have an x minus 4, it's being shifted to the right 4 units. Then the k means a vertical translation, or up or down. So if I were to add, let's say I added 7 to the end of this function, that means I would take this point and move it up 7 units because that's the vertical translation of it. And vertical is always the exact same sign that you see. If you see a plus, it means you go up. If you see a minus, you go down. And horizontal, again, is the opposite. So a lot of this is just going to be taking your parent function, moving it around in your x and y coordinates to find a domain and range that fits the square root function of the graph that you're looking for. All right, that is it.